Hello everyone. Welcome to the Mathematics 2 course. My name is Dr. Fatima Zohra Cheribet and I am here to help you to understand some key concepts in mathematics. In this video, I will focus on the first chapter of the tutorial which titled Matrices and Determinants. In this chapter, you will learn about many concepts which are very important tools in many areas of science and engineering. This course is designed for first-year science and technology students. I hope to make these topics clear and interesting for you. Let's get started. In this chapter, we have a few key objectives to achieve. First, we will learn how to identify and classify different types of matrices. Next, we will practice performing various matrix operations such as addition, subtraction, and multiplication. We will also learn how to compute the determinant of matrix and how to find the inverse of a matrix. Now that we understand our objectives, let's dive into the heart of the chapter and explore the fundamental concepts of matrices and determinants. Matrices and determinants are fundamental concepts in linear algebra, playing a crucial role in various fields such as engineering, computer science, and economics. In this chapter, we will explore the foundational principle of matrices, their types and operations, as well as the concepts of determinants, which provide valuable insights into matrix properties and systems of linear equations. Understanding these concepts is essential for solving complex mathematical problems and for their application in real-world scenarios. In this chapter, we will cover the following topics: matrices, definition, types and operations. Determinants, understanding what determinants are and how to calculate them. Inverse matrix, finding the inverse of matrix when it exists. To begin, let's define what a matrix is. The matrix is a rectangular array A of elements of K with n rows and m columns. In this case, A is a matrix of size m by m. We can represent A by the following form. If we take an element Aij from a matrix, then this element is located at the intersection of the row I and the column j. First index always indicate the row number, and the second index indicate the column number. For example, if we take the element A32, this element is found at the intersection of the third row and the second column. Now, let's look more closely at the different types of matrices. Row matrix is a matrix with only one row. Column matrix is a matrix with only one column. Zero matrix is a matrix in which all elements are zero. Diagonal matrix is a square matrix where all elements outside the main diagonal are zero. Scalar matrix is a diagonal matrix where all diagonal elements are the same. Unit matrix, also known as the identity matrix, is a square matrix with ones on the main diagonal and zero elsewhere. Upper triangular matrix is a square matrix where all elements below the main diagonal are zero. Lower triangular matrix is a square matrix where all elements above the main diagonal are zero. Next, let's discuss the fundamental operation we can perform with matrices. These operations are essential tools in linear algebra and are used in various applications. Addition, combining two matrices of the same size by adding their corresponding elements. Subtraction, subtracting corresponding elements of two matrices of the same size. Scalar multiplication, multiplying each element of matrix by the same scalar. Multiplication of matrices. In the case of matrix multiplication, We must first ensure that the number of columns in the first matrix is equal to the number of rows in the second matrix. Then, the matrix product is computed by taking the dot product of the rows of the first matrix with the columns of the second one. Transpose of matrix, flipping a matrix over its diagonal, turning its rows into columns and vice versa. Let's move on the concept of determinants. To begin, the determinant of matrix is a special number that can be calculated from its elements. Determinants help us understand important properties of matrices, such as whether a matrix has an inverse or the solution of a system of linear equations. We calculate the determinant of a square matrix of order n using this formula. For matrix of order 2, the determinant is computed by multiplying the elements on the main diagonal and then subtracting the product of the elements of the other diagonal. For matrix of order 3, the determinant is more complex. It is calculated by expanding along any row or a column using the determinant of submatrices of order 2 by 2. Now, let's see the concept of inverse matrix. We say that square matrix A is inversible if it exists a matrix B of the same order of A, such that A multiplied by B is equal B multiplied by A and equal to identity matrix. A matrix A has an inverse matrix if and only if the determinant of A is not equal to 0. The inverse matrix of A is given by 1 divided by the determinant of A multiplied by the transpose of the cofactor of A. To conclude, here are some key references to help you further understand matrices and determinants. Thank you for your attention.